NASA, the National Aeronautics and Space Administration, was established on July 29, 1958. This pivotal moment came in response to the Soviet Union's launch of Sputnik 1, the world's first artificial satellite, which sparked the space race between the United States and the Soviet Union during the Cold War. In its early years, NASA's primary focus was developing human spaceflight capabilities. The agency inherited the National Advisory Committee for Aeronautics and launched the Mercury program. The program's aim was simple yet monumental: to put a man in space and bring him back safely. The first successful American manned spaceflight was achieved by Alan Shepard on May 5, 1961, in the Freedom 7 spacecraft. This was followed by John Glenn's historic orbit around Earth in Friendship 7 on February 20, 1962, making Glenn the first American to orbit the Earth. These early missions laid the groundwork for more complex human spaceflight endeavors and set the stage for America's journey to the moon. Building on the success of the Mercury program, NASA initiated the Gemini program, which ran from 1962 to 1966. The Gemini missions were designed to develop space travel techniques crucial for the Apollo program, which aimed to land humans on the moon. Gemini missions tested important concepts such as spacewalking, or extravehicular activity, and spacecraft rendezvous and docking procedures. These missions demonstrated that humans could endure space for extended periods, paving the way for longer and more complex missions. NASA's Apollo program, initiated in 1961, set the audacious goal of landing humans on the moon and returning them safely to Earth, driven by President John F. Kennedy's challenge to achieve this by the end of the decade. The early tragedy of Apollo 1, where astronauts Gus Grissom, Ed White, and Roger Chaffee lost their lives in a cabin fire during a pre-launch test. The first manned success came with Apollo 7 in 1968, which tested the Command and Service Module in Earth orbit. This was quickly followed by Apollo 8, the first manned spacecraft to orbit the moon, capturing the iconic Earthrise photo. Apollo 9 tested the lunar module in Earth orbit, and Apollo 10 performed a dress rehearsal for the moon landing, descending to within 15.6 kilometers of the lunar surface. The historic Apollo 11 mission in July 1969 saw Neil Armstrong and Buzz Aldrin become the first humans to walk on the moon, with Michael Collins piloting the command module in lunar orbit. Subsequent missions continued to expand lunar exploration, with Apollo 12 demonstrating precision landing and Apollo 14 focusing on scientific research. The Apollo 13 mission, often called a successful failure, showcased the resilience and ingenuity of NASA when an oxygen tank exploded, but the crew returned safely to Earth. Apollo 15 introduced the Lunar Roving Vehicle, allowing for greater exploration, while Apollo 16 focused on the lunar highlands. The final mission, Apollo 17, saw the first scientist-astronaut, Harrison Schmitt, walk on the moon, marking the end of an era with Eugene Cernan's poignant words as he left the lunar surface. The Apollo program advanced our understanding of the moon, spurred technological innovations, and inspired future generations, with its legacy continuing to influence space exploration today, including NASA's Artemis program, aiming to return humans to the moon and beyond. Following the successful Apollo missions, NASA turned its attention to Skylab, the United States' first space station, launched in 1973. Skylab hosted 3 crewed missions, during which astronauts conducted scientific experiments in microgravity, studying solar astronomy, Earth observation, and biomedical sciences. Skylab provided valuable insights into long-duration spaceflight and human adaptation to the space environment. In 1975, the Apollo-Soyuz test project marked the first international human spaceflight mission. An American Apollo spacecraft and a Soviet Soyuz spacecraft docked in orbit, symbolizing a thaw in Cold War tensions and demonstrating international cooperation in space exploration. In the 1980s, NASA embarked on the Space Shuttle program, aiming to create a reusable spacecraft for a variety of missions. The first shuttle, Columbia, launched on April 12, 1981. The shuttle fleet, including Challenger, Discovery, Atlantis, and Endeavour, played a crucial role in constructing the International Space Station, ISS, deploying satellites, and conducting scientific experiments. The program, however, faced significant challenges, including the tragic Challenger disaster in 1986 and the Columbia disaster in 2003, which resulted in the loss of both crews. These events led to comprehensive safety overhauls and a re-evaluation of NASA's human spaceflight programs. Despite these setbacks, the shuttle program made substantial contributions to space science and technology, helping to maintain NASA's leadership in space exploration. The International Space Station, ISS, represents one of the most ambitious and successful international collaborations in space exploration. Launched in 1998, the ISS is a joint project involving NASA, Roscosmos Russia, ESA Europe, JAXA Japan, and CSA Canada. The ISS serves as a microgravity laboratory and a testbed for technologies required for long-duration human and robotic space exploration. Composed of modules assembled in orbit, the ISS has hosted astronauts from around the world, fostering international cooperation and scientific research. The station provides a unique platform for scientific research in various fields, including biology, physics, astronomy, and materials science. The ISS has advanced our understanding of human health in space, fluid dynamics, and combustion, and continues to be a critical asset for scientific discovery and international partnerships. In recent decades, NASA has focused on Mars exploration with notable missions such as the Mars rovers Spirit, Opportunity, Curiosity, and Perseverance. These missions aim to study the Martian surface, climate, geology, and the potential for past life. The Perseverance rover, which landed in 2021, is tasked with collecting samples for future return to Earth. NASA's Artemis program, announced in 2019, aims to return humans to the Moon by the mid-2020s. The program's goals include establishing a sustainable human presence on the Moon and testing technologies for future Mars missions. The Artemis missions involve international and commercial partnerships, reflecting a new era of space exploration. Looking ahead, NASA continues to push the boundaries of space exploration with ambitious plans. The James Webb Space Telescope, set to succeed the Hubble Space Telescope, will observe the universe in infrared wavelengths, studying the formation of stars and galaxies, the atmospheres of exoplanets, and the origins of life. Additionally, NASA is collaborating with the European Space Agency on the Mars Sample Return mission, which aims to bring Martian soil and rock samples back to Earth for detailed analysis. This mission will significantly advance our understanding of Mars and its potential for past life. NASA is also exploring partnerships with private companies like SpaceX and Blue Origin to develop next-generation space technologies and extend human presence deeper into the solar system. These collaborations aim to promote commercial space activities, foster innovation, and pave the way for the future of space exploration. From its inception to its current role as a leader in space exploration and scientific discovery, NASA's journey is a testament to human ingenuity, perseverance, and the unrelenting quest to understand our place in the universe. From its early days of rivalry in the space race to its current role as a leader in international collaboration and exploration, NASA continues to push the boundaries of what is possible in space science and discovery.